Alright, so in the previous video I showed you how to set everything up, and hopefully you managed to do that without any particular problems, right? So at this point, this is what the topology looks like. We have 4 nodes here, they all know about each other, and everything is good to go, basically. And the actual application that this is distributing is this data set that we have. And you can see from the menu here that we can print the current topology with the option 2, so you see what our nodes they have. You can also reprint the menu by using 9, and you can check if any node is suspected, and what that means we're going to go through later. You can execute a query immediately from here. You can print the store, and the store is the dataset, and it's empty. All the nodes have an empty dataset right now, so nobody has any data saved. You can check the clock, and what that means we're also going to go through later. So everyone has a clock 0 here because no messages have been sent yet. And you can execute the queries immediately from here, or you can use HTTP posts on this URL where you post to one of the nodes. It doesn't really matter, it depends on your configuration. But since I'm mostly using this as my master node, I'm going to be using that, but I could easily have been posting to any one of these, it doesn't matter at all. The syntax to store is in the README file of the project, so it is kind of like a data set, so you can't really insert stuff, but you have to, it's like a dictionary, so you set it or delete it or whatever. So in the body of the payload you have a query field, and there you give it a text string. And the first part here, parentheses, is how you're going to traverse the set. And don't be afraid of using keys here that doesn't exist, because they will be lazily created in the project. So here I'm using users, 0, and then username. So it's going to start by traversing into the users object. It's going to use index 0, and then it's going to set the username. This is the action. It's going to set it. And then it's defining the values here that it's going to set. So you can put JSON here, it needs to be escaped, or you can use real values, like I do here, for example. So that is the basic syntax. You can experiment with this if you like. So what you can do is you can use set, you can use delete, you can use get, and that is basically it. So if you're using Postman or anything, don't forget to set your content type to application JSON so you can parse it properly. Or if you have problems with that, you can just use the CLI here. I will be using Postman because it better reflects how you would actually consume this application in a real-world setting. But enough with that. Let's see what this actually does for us. So let's try it out and save a new user on index 0. And actually, let's do like this, so it's user 0, and let's see what happens. So you can see here, I got the response, the transaction was responded to me, the traversal that it traversed into users and index 0. The action was a set action, and the values were these, and this is the ID of the actual message. So the first part here is the node ID, the process ID, or the PID. And this is the Lampert clock time that we will also go through later what that means. So now if we check here, you can see that I'm logging a couple of stuff here. Something has definitely happened. So just printing the menu again, we can see that if we now print the store on this node, you can see that user 0 is set to this stuff that we posted. And this is, if you remember, this is on the port 3000. And this was the node that we posted to. But if we check the other nodes here, if you also print the store on the other nodes, you can see that these nodes also have the data saved, right? So it was successfully broadcasted to all the other nodes as well. And this is what the application is about. The cool thing about this is if we kill any of these nodes. Remember, everything here is saved in memory, so if I kill this node, the data is lost on this node. And that means that if I start it up, it should have amnesia. And you can see all the other nodes here, they start complaining that it lost it. This is called a failure detector. We will also briefly touch on the subject later, but you can see that all of these nodes are warning about this 3002 node, that it's lost it basically, and that it should be removed from the topology. But if I start it up again, it should have amnesia, but the thing is, like, it detects that it is behind and that it needs to catch up. And you can see now they stopped complaining about this guy because now it is back up. If I print a store now, it should be lost, but it is not, because it is recovered from the other nodes. And this is how we will get fault tolerance and resilience in the system, because you could have multiple nodes up. So if one, let's say that they're actually distributed on different servers, if any of these crashes, it doesn't really matter, because if you have a client that connects to this, then it just tries this node instead, and here it will get the data back. And if it is recovered later, then it will catch up on the log, and now it also has a store again. And you would always have the same store on all the nodes. So that is the basic use case of this. I think the proprietary solutions that exist out in the real world, most commonly I think Zookeeper is the one that also is going to be solving the problem that we are implementing right here. So I hope you enjoyed the demo, and I hope you also tried it out for yourself, and I also hope that you can see, like, at this point what this could be used for basically, and what kind of problems it solves, and what kind of different problems that can arise when we distribute the data like this. So I hope you guys liked it, and I will see you in the next video.